Hello. I'll be going over this problem for the chemistry textbook. Uh, it's 11.45 from Chemistry: The Essential Science. This is a phase change problem. So we want to first draw how a phase change will look like. We're going to go specifically for part B. So let's draw how a phase change will look like. So, oh, sorry. So as a solid, the heat increases and as temperature increases as energy increases, the solid will go like this, then it will be stagnant, and then it will increase. This is the fluid, then this will be stagnant, and then it will turn into vapor. That's the usual phase change. That's what we're gonna use to solve the problem for ethanol. So for part B, it says how much heat is required to convert the same amount of ethanol, negative 155 degrees Celsius, to vapor phase at 78 degrees Celsius. Okay, so we want to split this problem into four parts. The first part, we start off right here. I'm going to call this A. So put A right here. We want to use this equation, so it's mass times the specific heat times temperature to find how much energy that phase change will require. So we first need to use the specific heat of ethanol, which the specific heat is right here, and it's given in joules per grams Kelvin. So, and it gives us right here, it gives us a mass of 42 grams. So we don't need to convert it into moles. So first thing we do is take the moles, take the grams. So 42 grams of ethanol. I'm just gonna call it this. And then the specific heat of the solid is respectively, so it's 0.97. So 0.97 joules grams Kelvin. So the grams cancel out. So now we want to go to the temperature. Temperature is just going to be, so it melts at negative 114 and we start at 155. So if we just do the difference of that, that's going to be 41 Kelvin. I know it's in Celsius, but the difference will be the same. And this balance is going to eventually want it in kilojoules. So let's just convert that into kilojoules. So there's 1,000 joules in 1 kilojoule. So, So we see that these units canceled, and we're just left with kilojoules, and that will get us an answer of 1.67 kilojoules for party. Okay, let's box this. Okay, so now part B. Part B, we start off right here. So this place is where all of the ethanol would be converted into liquid water. So that's why it's stagnant. Okay, so because of that, we need the heat of fusion. and they give us the heat of fusion. The heat of fusion is of gas. Sorry, of this of the phase change is gonna be right here, 5.05 kilojoules per mole. So because it's per mole, we need to convert these 42 grams of ethanol into moles. So it's gonna be 42 grams of ethanol that's in 1 mole, and there's 46.07 grams 1 mole, and the heat of fusion, that's gonna be 5.02 kilojoules. So we don't even need to change it to kilojoules in 1 mole. Units canceled. We're just left with kilojoules. That's what we want. And we're gonna have a leftover of 4.5765 kilojoules. Okay, so now we're gonna go to this part right here. We're gonna call it C. Go right here, C. So now that we have C, we need to find the specific heat of the liquid and when it evaporates. So again, the heat of fusion, the specific heat is given in joules per grams per Kelvin. So we don't need to translate into moles. So we can just start off at 42 grams of ethanol. And that's gonna be 2.3 joules grams Kelvin. Okay, so now we need the temperature difference. The temperature difference, it says that ethanol boils at 78. So we'll just take the difference of that, and that's going to be 192 Kelvin. And now we just need to translate that into kilojoules. So one kilojoule as 1,000 joules, and that's going to be 18.55 kilojoules. Okay, so now that we have that, that's good. And now we're almost there. So A, B, C, and then D right here. We need the heat of fusion. Sorry, the heat of evaporation. And that's going to be 38 kilojoules per mole. So again, we need to translate that. So it's going to be 42 grams of ethanol. Uh, 32, 1 mole. That's 46.07 grams. So the diffusion would be 38. Seems like a lot. 38.56 kilojoules. And that's going to be 35.153 kilojoules. Okay. Oops. So now what we have to do is just see how much energy that took. So we're going to add this, this, and this. And we get a grand total of 59.947 kilojoules, or just 60 kilojoules. Okay, that's all.